So today we have Hemangi here with us, all the way from India to talk about 12 hours flight. And she's a software engineer at Epam. And she's going to talk about this Pydantic Logfire. It's a logging tool, a debugging tool for Python. So here you can Hemangi.
Hello everyone, hope I'm audible back there. So it feels really nice to be here. This is my first time in Hong Kong and first time at PyCon Hong Kong as well. So before we proceed, a little bit about myself. I am Hemangi Karchalkar. I work as a senior software engineer at Epam Systems, and let's get started. So if you can look at the heading, you will see it talks about a word named observability. So let's try to understand what is observability. Let's say we have a software system that we need to manage, and a well-defined software system has various non-functional requirements like availability, performance, and reliability. So these three aspects together make the state of the system. So how do we determine if the system is stable or not? We do that by we measure the state of the system at certain intervals of time. So how do we measure the state of the system? We do that through certain output measurements that we take of the system. So the process of using output measurements to understand the internal state of the system is known as observability. Did I skip something? Now, I think most of you must be familiar with the terms monitoring and observability might be a recent concept. So let's understand what are the concrete differences between them. While these two things are closely related, they are not the same. Let's start with monitoring. If we were to set up a monitoring system for a software application, the focus would be on application health, incident management, and fast fixes. And the primary sources of data for a monitoring system are logs and metrics. Whereas on the other hand, an observability platform focuses on understanding the internal state of a system. And the monitoring systems, they do not have the capability to provide insights into why an issue is happening. All they do care is about, okay, the response time is high. Now the job is left to the ops team to fix the issue and get the system back into a healthy state. Okay, let's consider this green line represents the healthy operation of a software system over a period of time t. And at some time, this software system encounters a failure. The time between this failure and the detection of this failure is known as time to detect, and the average of such times is known as mean time to detect. Now once the issue is detected, the software teams and the ops team work together to bring the system back to a healthy state. And once the system is back to a healthy state, the time between the detection of the failure and the time to resume the system to its normal state or a healthy state is known as time to repair. And the average of such times is known as mean time to repair. Now since the system is under proper healthy state, it starts functioning properly until it encounters a second failure. The time between resumption of the system to a healthy state and to the time it encounters one more failure, that is the next subsequent failure, is known as time between failures. And the average of such times is known as mean time between failures. And if you look at the diagram, the dotted line between the first and the second failure is known as time to failure. And the mean time to failure is the average time between the state of operation and the first failure of the system. So what does an observability platform do? Since it focuses on understanding the state of the system, it will get down this mean time to detect. It will also bring down the mean time to repair. And it will increase the mean time between failures. If you look like MTBF, the mean time between failures, the green line, the system should not the system should have a high healthy time. that is a high functioning time. And mean time to failure, it will also increase. But a monitoring system, since it focuses only on fixing the incidents, it will just get down the mean time to detect. It won't focus on the other three reliability metrics. Okay. Since we are dealing with observability, there are three important concepts. There are three pillars or three concepts that constitute the pillars of observability, that is logs, matrices, and traces. So let's go over them one by one. So what are logs? Logs are records of events and activities that occur in a system or a software application. Logs can have different formats, like you can consider them as an array or a list or a tuple which has a event that has occurred and which have logged some exceptions with a timestamp. So why do we need three pillars? Why not just logs are enough? Because logs don't provide aggregated data. Unlike metrics, logs don't provide aggregated data. For example, you might have logs, but you might not know how many requests failed in the last 5 minutes. Additionally, since they don't provide summarized data, you won't be able to spot any patterns or trends that are usually occurring. And they provide the overview of the system from a very low level. And they are not always structured or consistent. Example, you might have an application that is calling different microservices or different services. Like the database logs might be different than the ones of your main API or the API handling calls. And sometimes some service might have logs in JSON format, some service might have logs in XML format. So it is not possible to aggregate the data and spot some patterns or trends. Now the second pillar, metrics. Metrics are point-in-time values that represent the value of a measurement at a certain interval. If you look at the image on the screen, you will find the CPU utilization of the load generator service at 5:34 AM. So what is this saying? It is giving you point-in-time values. So just like logs, like why can't metrics be enough? Why do we need logs, metrics, and traces? The reason is metrics don't provide a full context of the system. Example, metrics may provide you the average response time or the average error rate or the how many requests failed in the last 5 minutes or 25 minutes, but they only provide a high level overview of the system. They do not provide a full context which is needed to understand why something happened. They provide limited visibility into the system. Like metrics don't capture the sequence of events and their timings. Say I'm debugging a complex issue, so I need to know what sequence of events happened that led up to a failure, which is something like metrics fail to capture. And lastly, with traces. So if you look at a trace, it consists of different components like spans. Like this trace on the screen, you will see it has 3 spans. So what is a trace? A trace is a collection of spans that represents a complete journey of a request or a transaction. And what is a span? So span is an individual operation, or it is a fundamental unit of work in tracing. It represents an individual operation in your system, and a span has various concepts and various information attached to it. Like it gives you the start and the end time of an operation. It also gives you some contextual information like the name of the service. Like example, if it is a GET request, your span will contain that it is a GET request. It will contain the function name. It will contain the route. It will also contain some query parameters that you are passing to it. Also, span can log around certain logging events and exceptions. Say if you have a span around a function and your function runs into an exception, your span can also trace that exception and log events. And on the other hand, span can also contain links to other span which are a part of larger operations. Like say if you look in the diagram, this is a GET request and some other custom code is being executed, and nextly database is span is being represented here. So how does the system know that these 3 spans are connected together? You have something known as trace ID, and every span has something known as span ID. So there is a parent-child relationship to it. So the trace ID will be common across all these spans, so that you can fetch that this trace has these many spans, that is the children. You can consider of spans like children and trace like a parent. Okay, so now finally we are coming to the topic. So what is Pydantic Logfire? The most common question that I have been asked is, what is Pydantic Logfire? Is it a library just like Pydantic, or is it a tool? But it is more complex than that. It is an observability platform, and there is a free open source component to it, which is the Logfire SDK. This is the code that we as developers would run, and the SDK is built on top of OpenTelemetry. OpenTelemetry is also an observability open source project. So in other words, all the code that we'll add in our code is free and open source. And this Logfire SDK will send some data to the Logfire service. This Logfire service has their own web UI and database. However, this Logfire service is a commercial product, which is built on Pydantic's own infrastructure. Also, this Logfire SDK can send data to console, terminal, or other exporters. Some features of Pydantic Logfire. It is built on top of OpenTelemetry. Since it is built on top of OpenTelemetry, it simplifies a lot of existing integrations with OpenTelemetry based tools, and it seamlessly integrates. Secondly, it supports, you can query your logs using SQL. You don't need to learn another query language or another language for querying. And it also has support of ChatGPT while querying, and ChatGPT performs really nice with SQL. Anyone who has used OpenTelemetry here? Have you encountered any, like, what I find is, like, being using both these things, what I have seen is Logfire removes or abstracts the complexity of setting up OpenTelemetry. Like, you just have to do pip install Logfire, and under the hood all the dependencies and all the required dependencies that are required will be installed. So you don't have to perform or worry much about the setup. And it also provides, they have their own in-house inbuilt support for OpenAI integrations, and you can analyze the behavior. And people might say, since it is built on top of OpenTelemetry, what is the newness that you're offering? OpenTelemetry was built for all programming languages. So they have like something which is specific to Python, like Pydantic classes or data classes, which are not present in other programming languages. It is very difficult to validate those. But with Pydantic Logfire, you can validate even the context manager, your Pydantic classes, your data classes, something that is very native to Python. And the newness about this thing is, the people who built Pydantic Logfire are not observability platform building experts. They are developers. We want to focus on not the configuration, we want to focus on the core functionality. Example, the core functionality of a calculator is to perform mathematical computation. You don't have to worry about how do I enter the number. If the setup is a hassle, then people would not stick to this tool. So since they are developers, they understand the pain point of a developer. Like, the configuration takes a lot of time. So the configuration is like a cakewalk here. We'll have a demo shortly. Just explain. So in the demo, I'll be using the term instrumentation. So I'll just let you know what is it. I'll be adding a piece of code to my own code. My own code, as in, say, a fast API code or any Python code. I'll adding a piece of code so as to capture certain observability data that will look like traces, matrices, and logs. So that is something what I mean by instrumentation. And let's have some demo. Is it visible, or do I need to increase the font size? So I have a fast API application setup, and this is a very basic URL that is set up. And when you do pip install logfire, you will see this .logfire file in your VS Code. So this is just like a .env file where you can specify certain of your configurations. But this is the virtual environment that I'm using, my env. So if you just go a little bit into the libraries and scroll down, you will see there are packages of OpenTelemetry. So it is built on top of OpenTelemetry. So anything that OpenTelemetry supports, this Pydantic is going to support. A bit about its internals and okay. To get it started, you can span around the APIs. You can instrument the requests by using Logfire. All you need is pip install Logfire, step 1. Step 2, you'll be redirected to their web UI where you have to create an account. Step 3, simply import on line number 7, import Logfire, initialize it, logfire.configure. There are different parameters that you can add to this logfire configure, and simply they have their inbuilt auto instrumentation, logfire.instrument fast API app. And I have this Ubicon running, so just if I simply copy this link and just give me a second. This is the web UI I was talking about. Now we'll raise some requests and let's see. Get started. Okay, so let's see, this log should be evident there. So this is the trace that we have gotten. Okay, this is the get request, and along with it, you are getting certain arguments. And if you can see the name of you have a service name, since I named it as an unknown service, you will get there. This is the trace ID that I was talking about. This is the time span it took, the duration, and this is the span ID. And also all the arguments that you need are provided here, and the attributes. And you can query SQL query along here. See, if I make 2 to 3 requests, and for querying you don't even need to explicitly type. You scroll down here, you will see a funnel icon. Just click there, something is copied, just paste and hit enter. Otherwise, there are filtering options available here as well. And if you go to this raw data, you will understand what it does is it takes your request and the response and the entire life cycle of this transaction, and it breaks it down into JSON. And how does it do? If you go to this explore tab and click on this database icon, it has a table name records, it stores everything inside. That is why it is helping you to query in SQL. So again, go back there, you will see certain logs. And yeah, the second use case I will explain is, since web application is one of the most promising applications like people use, but you can use it for logging anything. See, if I have a normal Python function that takes in 2 numbers and divides them. So I can create a span for the function using this decorator @logfire instrument. The first 2 steps remain common: import and configure. And third, if you have a function, you can instrument it. And if you don't have a function and it is not a web application, what you can do is you can start a context manager with logfire.span. So let's run into this. Okay, I will firstly remove these exception handling block, so that let me see if it is able to capture some exceptions. And let's run this file. Okay, it is asking me to enter the first number. I'll enter 10. Second number, I'll enter 0 because I want it to run into an exception. On the terminal, I do have that error, but now let's go to our, okay, so it caught the exception. It also got the file path, it also gave you the line number, and it gave you the exception trace back as well. It gives you a cleaner view. One more functionality that I would like to highlight is you can create your own dashboards here for view. And lastly, if anybody has used webhooks, you can create alerts using webhooks. You can give the alert name. You can say like raise an alert or notify me if say some service goes down or any condition is matched or not. And you can set a timer as well. Before we stop, please take out your phones and maybe you can scan. It's a very short one. I'll go to the next slide. Look at your phones. I think let's get started. Make sure you remember your names. Who are these two ones? And now who are these four ones who have answered wrongly? Tell me your names. And before we proceed, the last question is going to be a deciding factor. So please be very attentive. Very important question, has the maximum number of points. Okay, so let's start. 1, 2, 3. Let's go. And if anybody answers wrongly, they have to meet me in person. I have all your contact information because you guys scanned here. Almost everyone is right.
Congratulations, Snuggles.
Nothing. Thank you.